Hi, my name is Nivedita Bora and my student ID is 32128034 and my team members are Manav, Kishan, Raj. Today we are going to do a video presentation of the topic deep learning, neural network and their impact on software engineering. We chose this topic because deep learning and the neural networks are the vast topic of artificial intelligence and we are very much interested in this topic so we can gain some knowledge while researching about the topics and get to know more. Introduction to subject. Artificial intelligence is a common term in the world these days, but artificial intelligence is a broad topic which is divided into two main subtopics. The first main topic is machine learning, and the major topic is deep learning. Deep learning has revolutionized many fields, including computer vision and robotics. At its core, deep learning tries to imitate the human brain's capability to grasp and resolve complex problems by extracting vast amounts of data through interconnected layers of artificial neurons. Now, let's talk about deep learning. Deep learning. Deep learning is a part of artificial intelligence that trains computers to operate features in a way that is stimulated by the human brain. We can use learning techniques to motorize tasks that normally need human intelligence, such as reporting images or transcribing sound file into text. Moreover, it refers to the training and application of neural networks with many hidden layers, enabling the artificial to learn hierarchical representations of data. Neural network. Neural networks are analytical models influenced by the formation and role of the human brain. They are a basic element of the artificial intelligence and have found extensive appeal in numerous fields such as pattern recognition, classification, regression, and decision making. Furthermore, neural networks are the influential computation models that emulate the conduct of the biological neurons, enabling devices to grasp from data and perform complex tasks.
Okay, so let's move on to literature review. AI is a branch of applied computer science wherein computer algorithms are trained to perform tasks typically associated with human intelligence. The AI technology is interdisciplinary in that it involves all engineering subjects such as computer science, electronic, and communication. Besides, it has many interlinked applications in basic science such as home science, environmental, chemical, physics, and biological, to name a few. Apart from this, it has interlinked with humanities and social science such as linguistics, psychology, society, history, and urbanization. It means that these AI subjects is scrolling toward disciplines to provide more application in all human living and non-living environment around the clock. In sense, AI refer to machine performing the cognitive functions typically associated with human, including preserving, reasoning, learning, and interacting. Besides, there are many studies which are booming in the field of AI due to its immense application to all organizations. For example, a study by Zhang in 2090 stated that AI has been widely adopted in many important application domains such as speech recognition, computer vision, autonomous driving, and AI for such good. A growing number of AI applications and devices are helping humans satisfy a basic need to connect with others. Translator help ensure that the AI application developed to address business needs and adoption goes smoothly. After that, methodologies of deep learning and neural network. Deep learning is a subset of machine learning that use artificial neural network with many layers to learn represent data. These models are trained on a large data set and can learn complex pattern and representation. The goal is to automatically learn hierarchical features representation from a data to high level abstraction. Methodology typically involves the following steps. The first and foremost one is data set presentation. Collect the end presentation data. Second one is model architecture. Define the neural network architecture. Third, training. Optimize models parameters using back propagation and optimization algorithm. Fourth one, evaluation. Measure the model's performance on a held out validation set. Fifth one, hyperparameter tuning. Adjust the model's architecture and training parameter to improve performance. Sixth one, deployment. Use the trained model for prediction or control. Then, methods of deep learning. There are four total methods which we are using in deep learning. The first and foremost one is dense layer. Each neurons in dense layer is attached to a neurons in the earlier and subsequent layer. Second one is convolutional layer. This layer are used for image and signal processing tasks. Third, recurrent layer. These layers are used for sequential data such as text or time series. They have a feedback loop that allow information to be passed from one time steps to the next. 4. Pooling layer. This layer reduces the spatial resolution of the input data, which help to prevent overfitting and reduce computational complexity.
Now, methodologies of neural network. Neural network typically involves different steps, like first dataset preparation, collect and process the data, including splitting it into a training, validation, and test sets. Second, model architecture. Define the neural network architecture, including the number and types of layer, the number of neurons in each layer, and the activation function. Third one, initialization. Initialize the model's weight and bias, typically using the random values. Fourth, training. Optimize the model's parameter using an optimization algorithm such as the Stochastic gradient descent and Adams. This involves the iterating over the training data multiple times, adjust the model's parameter to minimize the loss function. Fifth, regularizations. Apply regularization techniques such as L1 or L2 regularizations, dropout, or early stopping to prevent overfitting and improve the generalization. Sixth, evaluation. Evaluate the model's performance on held out validation set and adjust the hyperparameter as needed. 7. Testing. Evaluate the model's performance on a held out test set to estimate its generalization error. And final step 8. Deployment. Deploy the trained model to production environment where it can be used for a prediction or a control. The methodology for building a neural network requires expertise and experience, as well as deep understanding of the problem domain and the data. In summary, the methodology for building a neural network involves preparing the data, define the model architecture, initialize the model's all parameter, and training that model. After that, regularize all the model, evaluate its performance, and then finally deploy to production environment. Critical analysis and discussion and their impact on software engineering. Deep learning and neural network have revolutionized the field of software engineering in numerous ways, like from image recognition to natural language processing and its beyond. Here's a critical analysis and discussion and their impacts. First, automation and efficiency. Deep learning has authorized software engineers to self-operate their tasks with previously time-consuming, error-prone tasks such as data classifying, anomaly detection. Second, complex problem solving. Neural networks excel at holding complex nonlinear problems that are tough to solving with using a traditional algorithm. It has revolutionized the field such as computer vision and speech recognition. Third, scalability and flexibility. Deep learning models can scale pick up to huge quantity of data and a complex problem such as a social media, analytics, recommendation system, and a financial forecast. Fourth, challenges in development and deployment. Despite the countless advantages, deep learning models also pose the confirmation, especially in terms of the development and deployment. Building and training neural networks and need a specific knowledge and expertise, as well as they need a specific requirement for the computational resources and careful optimization to ensure the efficiency of performance. Fifth, ethical and social implications. Too extensive assumption of deep learning technologies also elevate the main moral and collective suggestion for the software engineers. 6. Continuous innovation and research. It is a quickly developing field with the latest techniques and architecture being succeed continuously. Software engineers must stay up to date with the most recent advantages in order to grip the full possible of neural network. And in conclusion, deep learning and neural networks have had a great impact on software engineering, enabling the engineering to the automation task, resolve the complex problem, and develop the innovative application across a wide range of domains. However, the widespread adoption of these technologies also presents the challenges in terms of development, deployment, ethics, and social impact.
Future directions of deep learning and neural networks. As of January 2022, the field of deep learning and neural networks was evolving rapidly, and several future directions were already emerging. While we cannot predict specific developments beyond that point, we can outline some potential trends and directions based on the trajectory of research and technological advancement up to the time. Continued architectural innovation. Deep learning architecture have been evolving rapidly, with researchers designing new network structure to address specific tasks and challenges. Self-supervised and unsupervised learning. While supervised learning has been the dominant paradigm in deep learning, there is growing interest in self-supervised and unsupervised learning methods. Continual lifelong learning. Traditional deep learning models are typically trained on static datasets, but in real-world application, data distribution may change over time. Federated learning and privacy-preserving technique. Federated learning enables training of models across decentralized data sources without the need to centralize data, thus addressing privacy concerns associated with data sharing. In conclusion, deep learning and neural network methods have transformed numerous fields such as computer vision, natural language processing, and robotics. These techniques have authorized unprecedented presentation in tasks such as image recognition, speech recognition, language translation, and autonomous driving. Lead advantage of deep learning and neural network include their ability to automatically learn intricate patterns from huge amount of information, their ability to grasp high dimensional data efficiently, and their adaptability to various problem domains. Explaining the conclusion made by deep learning model, ensuring their robustness against adversarial attacks, and scaling this representation to handle massive datasets and computer resource are energetic area of research. Moving forward, advancement in deep learning and neural network technique are expected to continue, driven by development in model architecture, training algorithm, and computational resources. This advancement will likely lead to further breakthrough in artificial intelligence and contribute to solving increasingly complex real-world problems.